All right, here we go. Welcome to lesson 11.4 Geometry Notes, three-dimensional figures. So here's our first look at, in this course, we kind of get to some of that, I don't know, I think kind of cool stuff, the cubes, the pyramids, stuff like that. We start talking three-dimension. We'll eventually talk in the upcoming lessons volume. So the second half of this chapter focuses on three-dimensional figures. So we'll go over a little vocab to start. It's not an overly long lesson. We'll do some vocab, a couple different classifications, and then we'll talk these cross sections and revolutions or solids of revolution. So I think we can get it done. Let's try to keep it maybe under 20 even. Here we go. All right. Well, maybe I thought I was clicking on that one. Here we go. Classifying solids. So when we start talking about geometric solids, one of the first notes we took was, just as a heading, we said solids or geometric solids. That's our three-dimensional figure. All right, it's a region bounded by, could be flat like we're seeing here, or curved surfaces. I'll say some words here that I'm sure you've heard: sphere, cylinder, cone, stuff like that. But we're closing off a region of space. Okay, that's our definition of a geometric solid. What we should be thinking when we think of three-dimensional. So within that geometric solid category, we have what's called polyhedra. That's the plural, or like a singular polyhedron. So this is an example. That's a polyhedron. It's under this bigger category of geometric solids that all the what we're going to call faces, all like the sides of it, are polygons. Okay, so the other three pieces of vocab that we added were faces, edges, and vertices. We've heard vertices before, but I think the picture's pretty good. It's worth maybe adding to our notes we did in class, as far as just having something to kind of represent. Your edges are where your faces come together, so the segment where two faces come together, and then the vertices is where three or more actually edges potentially come together. We'll see that in a pyramid. So that's kind of the basics. So polyhedron specifically, it takes all curved. It takes the curved surfaces out of it. Okay, so that's kind of if we're branching it out, just big picture here, we had geometric solids at the top, three-dimensional figures. So within that, we'll have two different types: our polyhedra, plural, and then we're going to do this actually on the next slide. Not polyhedra. Okay, so just to kind of put it together as far as what's going on there, everything's that we're going to talk about is a geometric solid. There's just two different types that we're going to look at. Okay, here it is right here. So if you wanted to go back and almost set it up as far as just geometric solids, and we're breaking it into two categories. So within each category now is where we start to give specific names to these different types of geometric solids. Okay, let's start here. Yeah, I'm assuming most people have kind of heard of these. If not, there's two types that we'll talk about, two specific types of polyhedra, where each face, well, I guess this isn't true as a rectangle, but is a polyhedra. We'll define it a little more in the next part when we talk about naming them. But is a prism, a geometric prism. Okay, this was what we would call a rectangular prism. Sketch it, add it to your notes, and then a pyramid, which again, I'm assuming that's something we've seen, we're hopefully at least familiar with in some regard, a pyramid there. Okay, so the not polyhedra must all have, but I guess what's the connection here? Every face is a polygon, right? Rectangle, 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 all the way around. We got triangles. We got looks maybe like a square on the bottom. We can't be super specific there, but if I look at what we're just calling not polyhedra, there's still stuff we're going to work with. There's still volume there. There's still different things we're going to do with them. They all involve some sort of curved surface or rounded surface. So a cylinder, a cone, a sphere. We drew this setup, added it to our notes, just to kind of illustrate the difference between kind of our two types of geometric solids. Okay. Kind of the last part is, how do we talk about today? I guess the rest of the lesson, for the most part, I guess not everything, but focuses on polyhedra, either a prism or a pyramid. So we name them using the bases. So you would say, like the name of the however whatever the base shape is. So in this case, I guess it's good to reference here. Our bases is a pentagon, right? So I've got a base and a base that are both pentagons. We would say this is a pentagonal, and then you just say, oh, prism. Now, how do I know what the base is? Sometimes people get confused there. Like, it's not always the bottom. Sometimes people think of it, and I'm using air quotes that you can't see, but the bottom of the figure. We can get into trouble there. There'll be a couple examples we'll look at that we got to be careful that we're not thinking the bottom, whereas I know this case that is, but how do I know if it's the base? The bases are going to be parallel, basically. Okay, so if I look at this figure and kind of am able to visualize it, I've got a pentagon on what we would think of as the top, maybe, and a pentagon on the bottom. All these other faces are what? I would say rectangles. Okay, and that's how a prism is going to work. You're going to have two parallel bases and then a bunch of other rectangles kind of going around as the other faces. Now, the one we just looked at, that's kind of the odd duck exception there, where basically you almost have three sets of bases. This is what we would call a rectangular prism. So I've got, you could in theory call kind of your top and bottom your bases. You could call your left and your right a pair of parallel bases, right? Or your front and back. So that one's kind of specific. A rectangular prism is a little bit, not necessarily an exception, but it's unique in that you could kind of call any pair of opposite faces your base. Okay. For a pyramid, you still name it using the base. So I may be looking more at this one. I'm going back and forth. If we knew this was a square, I would say, hey, this is a square pyramid. Or let's say we knew that the base was a rectangle. Some of those should probably be dashed, but whether it's square or rectangle, I could say, oh, that's a rectangular pyramid. The one, kind of the odd duck, unique one for a pyramid is a triangular pyramid, where my base is a triangle and all these other panels, all these other faces are all triangles as well. So this is kind of like, this is the equivalent of the rectangular prism in that we could, in theory, lay this on any portion or call any side the base, I guess. Okay, but the way it's drawn, we've kind of got the bottom, we're calling the base. Base is a triangular pyramid. So hopefully I didn't lose it there in naming. We'll practice it right here. I've got to separate it as 6 separate, but it's all the same kind of concept, 1A and 1B, just to split it up a little bit. So obviously in class, I would have given you a handout. Some of these get tougher to draw, but you should still, if you're doing this at home, you should try to sketch the figure. Okay, classify, basically name each one. Tell, is it a polyhedron? Yes or no? And if it is, name it. Okay, we could even name something like this too. There'll be one in the next one that we're just not able to name. But all right, so here we go. Going through it, I look at my bases. So I'm using probably the most specific piece that I have. So when I look here, I see just on the markings that that's a rectangle, and I've got a rectangle in the back as well. So we would call this a rectangular. Yes, I guess we should say, is this a polyhedron? Yes, it's a rectangular prism. All right, awesome. How do I know it's a polyhedron? If I asked you to explain, how do you know this is a polyhedron? This is another one. Yes. Why? Because every face is a polygon. What is this one made up of? Triangles, 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 triangles all the way around. And then our base that we're going to name this is a 1, 2, 3, 4, 5, 6-sided figure. So we're going to call this a hexagonal pyramid. As far as just answering the questions here, then for part C, is this a polyhedron? No. Why not? You could just say something along the lines of curved or rounded. Oh no, I squeezed out there. Surface. For this particular one, we could call it a cone. We just talked about that a little bit ago. So it's not a polyhedron though, because of that curved rounded surface. All right, a couple different looks here. Same deal, same question, same setup. Tell whether the solid is a polyhedron. If so, name it. So different type of pyramid here. It's definitely a pyramid. Hopefully we're seeing that as pyramid. By the base, I can tell equilateral and the right angle makes that a square. So we would call this a square pyramid. We'd answer the question, is this a polyhedron? Yes. Two is the one that I was talking about before. We're going to say no because I can see it's got this curved surface. It's not really a face because face is kind of defined specifically for polyhedron, for a polyhedron, but it's got a curved surface, so it's definitely not a polyhedron. And we don't really have a name. I guess you could kind of I would say maybe like a half cylinder, but I don't necessarily know that that's half. It's like a cylinder that's kind of been dissected, but just it didn't say to name it. It says only if it is a polyhedron, name it. Probably the toughest one that we were the least gotten in class, I guess, was this one. Sometimes people will see this as a pyramid. It kind of looks like a pyramid. I mean, I guess I understand why we might call it a pyramid. This is a prism. And then the other part of this one, too, is what's the base on this one? This is one of the first ones we're seeing where the base isn't like on the bottom, right? If I look at the bottom, what shape do I see? I see what looks to be like a rectangle, right? Where my bases are these right triangles that we're seeing. So this one is what we should call a triangular prism. So yes, it's a polyhedron. All right. So that's the main focus actually of this lesson is just being able to name and talk about and identify different types of geometric solids. Okay, so that's kind of the first part of it. The other two, there's two follow-up here. We'll do a brief note. Let's just do it. Let's jump in there. Cross sections. So that can be your next heading, cross sections. And that's probably a term you would maybe have heard before. When we're talking about what we're talking about in geometry with a cross section is basically like a plane or even just like a knife, like cutting through one of these geometric solids. And the cross section is maybe put like as for additional note would be like two-dimensional. So we're back to talking about circles and squares and rectangles and triangles. I think it's kind of cool. So I've like here you've got the same blue cube. It's a I guess you could call it a square prism. Every side is a square, but hopefully cube resonates with us a little bit. But depending on how I slice it, if I slice it kind of parallel to the top and bottom, and I look, what shape would I see? If I just kind of picked up the top and looked at the cross section, I would see a square. Okay, so the purple is meant to kind of represent what the cross section would be. So that same cube, if I slice it on a totally different angle, like corner to corner, and I look at, I kind of pick this top piece off and just look at the bottom of it, of where I slice through, I would see a rectangle, and then just taking a little corner off, we would see a triangle. So it's unique. It's weird. It's okay. So same shape, bunch of different ways to kind of slice it. So again, hopefully a relatively quick, and I don't mean to say easy or sound like it's easy, but I also don't want to spend forever on something that doesn't need as much time. I've got different I guess not even polyhedra, because I've got cylinders, I've got cones, I've got spheres being sliced by the plane and the solid. So the cross sections, it's all going to be two-dimensional answers. So like here I would say this is a hexagon as far as what I would see once I slice that. With the pyramid here, I'd see a triangle. I like C. It's the cylinder that I'm slicing straight through the top and bottom in this case. And I kind of if I were to open that up and look at it, I would see a rectangle. Would be the description. So that's what I mean by describe the shape. Just tell me the shape. Cone cutting across, kind of parallel to the base, we'd see a circle. As well as our next one, our sphere, if we kind of cut it along either the equator or wherever we cut it, as long as if we pass through the center of the sphere, we'd also have a circle. And the last one, it's that same almost cube that we had on the previous slide, where if I kind of cut not quite corner to corner, but not just taking the corner off, you get this, you could also end up with what looks to be a trapezoid. So there we go. There's cross sections, not overly deep. Just make sure we're able to recognize kind of what is a cross section if I use that term, and what am I asking for. Two-dimensional answers, I guess. Okay, last one, or last concept here. Again, kind of a shorter one. Your heading can be solids of revolution. So basically what we're talking about, just to summarize here, you can go, a lot of this is good, But basically now we're going the other direction. If we take a two-dimensional figure, okay, a two-dimensional shape, and we kind of like glue it to an axis, so it looks like a flag almost. Now picture you're grabbing the fingers on that, you're taking your fingers and grabbing the arrows and spinning this around, or like a Post-it note on your pencil, right? You spin it around. What three-dimensional figure would be formed kind of in like the wake of this Post-it note spinning around if we were able to fill it all in on its lap? So you can see it right here. I mean, I think it's a pretty good illustration. When we rotate this rectangle around, it would pass all the way around and create what we would describe as a cylinder. Okay, so you're going from two-dimensional, rectangle attached to what we call the axis of revolution, rotated a full way around. What would we kind of create? All right, let's do it. So what do the problems look like? Well, we're kind of seeing that one. So I do ask you, this is kind of one of the times I'll ask you to sketch it a little bit. So let's read the directions. Sketch and describe the solids of revolution. So I've got a triangle, I've got a rectangle, and I've got looks to be like a half circle, semicircle kind of glued to our axis of revolution. We're rotating it around those lines. What do we come up with? So the first thing I'm asking you to do is sketch it. So keep your axis of revolution kind of in the same position. And what would we be coming up with? This is going to look, once it gets all the way around, we'd create a cone in this case, right? So that's the first part. Well, I guess it's the sketch I did. And then when it says identify the solid, I'm going to say cone. The description part's a little bit weird. They're all going to actually have a curved portion of it. So we would say what I'd be looking for here would be the radius of this cone is going to end up being that 3. So that's why there's the numbers there. And then the height, which we'll talk about these in upcoming lessons, the height would be 4. So that's kind of what I mean by describe the solid. A cone with a radius of 3 and a height of 4. All right, we just saw this one on the previous, like more on the notes portion. So once I revolve this around our axis of revolution, we'd say, hey, yep, that's a cylinder. So we would say cylinder. And then what are like kind of the components of it? We'd have a radius of 6. Let's just write it out. Radius equal to 6, and then a height of 8. Okay, my 8 would be about right here. All right, then the last one, when I rotate this half circle around my axis of revolution, we'd end up with, here's how I would draw a sphere. I'd kind of center up a circle there, draw like a little curved equator, like we're drawing a globe or something like that. So there's my sphere. Not beautiful. I'm an artist by no stretch of the imagination, but we should definitely call this a sphere. Hopefully we're seeing this. Like you'd be able to do that sphere. And then this one's a little bit unique in that the only feature that we have would be a radius equal to 7. So however you measure, there's no height on that one. So use those. They're similar to ones I'll ask you to do on a homework or a quiz section. So did we do it? Did we keep it under 20? I forgot to look at the start time. I guess you'll see the time on the video when you click it. So we made it. Did we do it? Classify. The major focus is right here. Being able to classify, talk, and communicate and recognize and identify geometric solids. I'm not saying they're not important, but we did. We hit them. The cross section and the solids of revolution. Yeah, we got it done. So that's it. A lesson 11.4 done. I think under 20 minutes. Yeah, I will see you in future lessons.